Okay, good afternoon everyone.
Afternoon.
Hope you've enjoyed your lunch. You're ready and excited to see something different, at least in terms of technology stack. So, as you know, that we announced developer preview of event-driven Ansible last year at Ansiblefest. And since then there's been a massive kind of drive from the community in terms of building things like source plugins, use cases are really important. And we're going to kind of go through just a little bit of the basics around what event-driven Ansible is kind of all about. So there's obviously going to be a lot more information throughout the week with some really cool labs. There's lots of cool labs around this. But let's dive into this and then take kind of like a slightly different approach to what we can do with event-driven. So, if we look at the basics of event-driven, event-driven is kind of focused around three pillars or three silos, right? So when we're talking about event-driven, we're talking about sources, rules, and ultimately actions. So what does this mean? This means that with Ansible and with event-driven Ansible, I can actually listen to a source. And when we're talking about sources, we're talking about intelligent sources, right? So this is sources that are coming from monitoring systems, monitoring tools, where kind of the intelligent part is done, right? The system has gone through its process, it's decided there's an issue here, etc., and it's able to present us that information. So event-driven Ansible can hear this, listen to this, and obviously based on that act. Now how do we get to this action? That's all going through rules. So you'll see that we have this rules engine that's running, and effectively we go through this list of conditions that we build, and based on those conditions we can have actions. And those actions can be anything from remediation to, just like ticket enhancement or anything like that. There's a big drive between observation, obviously, and this tool set. Not everything is around self-remediation, right? So a lot of the times people hear about self-remediation because we're getting triggered by an event, and it can be quite scary for some people. I know when I've been working around NetOps with event-driven Ansible, that's something that most of the network engineers don't want to hear about. They don't want to hear about changes going on in the network while they're sleeping. So the use case for observation is a really good one for that, because what do we want to do? Something happens, we understand something's gone wrong. Instead of going through the process of having to troubleshoot everything manually, let's get the troubleshooting out the way, let's get a ticketing system out, let's update the tickets, let's get that all going. Event-driven Ansible is there to plug all of those holes, right? So event-driven Ansible is really quite powerful. If we look at how this is all built, you can see that we have our event source, we have our processing where all of our rules and our conditions take place, and then ultimately we have our automation, which is the action. Now in this example, we do have like another step, which is the messaging layer. And this is quite important because I think it's a bit of a cheat, but if you don't have like a source plugin that's been built, what can you do? Or we can listen to a message queue. So you can go and you can build a message queue, you can publish all your messaging and your notifications to the queue, and then from there base your actions in terms of what you're trying to do with what's coming out of that queue. So this is what it looks like from a simple perspective, right? We have our event sources, we have our rules, we have our automation. So we still leave it all open, so you can still decide what you want to do, right? So if we have a look at how we build all of this, we have a fundamental, new component to Ansible, and this is the Ansible Rulebook. So throughout the week, you're going to hear a little bit more about Ansible Rulebooks. And you're going to obviously see plenty of examples, but this is a pretty straightforward one right now. You can see that we are breaking down what we're looking for. So what are we looking for? We're looking for a source, we have a list of rules, which is our conditions, and then ultimately we have our actions. So everything that we're talking about today, at least, is based on a thing called Ansible Rulebook that you can actually grab from a Git repo. It's been there since Ansiblefest last year, and we're running all of this inside CLI, right? So the way this all works is pretty straightforward. Like I said, we listen to the event, we match the condition, and based on that, we then trigger our action. Now, there is a question around, okay, well, we have Ansible Rulebooks. What's the difference between the Ansible Rulebook and the normal playbook that we know, right? Well, let's break it down. The playbook, we know that we trigger a playbook, what happens? It goes top to bottom, sequentially, and it does what it needs to do, and then it exits. Now, when we run Ansible Rulebook, it's different because it never exits. What it does is it sits in this loop, listening and evaluating the events. So, as an event comes through, it decides what it needs to do based on that whole condition system that we work with, and then it will go and it will trigger whatever it needs to take place. The only time that this will actually exit is if it gets what we call a shutdown event. So this is when you actually send something through your source to say there's a shutdown event. From there, obviously, we can exit that. Otherwise, this just continuously runs and constantly evaluates. So this is a typical use case, or what we're looking at in terms of how this gets processed. A lot of times we're talking about this is typically a if-else type of methodology, right? So we match one, goes to the next one if it doesn't match. If an event doesn't ever get matched, it gets dropped, right? If an event does get matched, it will then process to the next step, which would be the action, and then from there obviously work. Now we're going to basically show you an example of this mechanism, but we're taking it from a different perspective. So currently, the Ansible integrations that we're playing with or we're working with, you can see there's a lot of these. We've got the partner-driven integrations, things like the download trace plugins, etc. We have the community plugins, which is really important. Obviously, that's where we kind of focus in, where we have things like Kafka, we've got the Kubernetes plugin. So this is stuff that's constantly working. One of the key things here is also the webhooks. So we're going to look now at a webhook and how the webhook basically would work. So we did say that this is a kind of chatting about event-driven Ansible, and that kind of leads us to the use case. So we're going to think about something a little bit different. Instead of having a system that is basically telling us what's going on, and from there basically triggering what we need to do, what we can do is we can actually create these events ourselves. So if we have a chat interface, so we have a chat system running, based on what we want to do, we can actually trigger event-driven Ansible to actually go ahead and do different things for it. So imagine your typical organization where we have these things like we have a ticketing system in place, we have all of that, but we already have all of the technical teams on a company chat system. So why can't we work with that chat system? Why do we have to, let's go through the ticketing system, wait for that response, etc. Maybe sometimes things are a bit more critical, or we want to go and just check something. We want to, trigger troubleshooting on our network, or trigger, some check on the infrastructure. Maybe it will be kind of nice to be able to trigger that through a chat system, right? So this is kind of the way at least I was thinking about it. So this works a bit different. So we use the chat system ultimately as our source. And you'll see I'll be working with Mattermost as a simplified example. Obviously, it's pretty similar to Slack. And what are we going to do? Right? So we're going to use what we are trying to do in terms of a command or some kind of prompt. That becomes our source. Right? So that becomes part of our payload that we're going to use from a webhook. We're going to push that through to event-driven. And ultimately, event-driven, because we've gone and we've built those conditionals, we can decide, what should typically happen in terms of, processing that. Hence why we have some kind of automated action. Feedback is obviously very important, right? So this will come on a little bit later, but effectively, we also want to enhance this use case by making sure that there's always some kind of feedback. So you would also build, ultimately, some kind of notification that will come back to that chat. Obviously, we don't want to go just start typing things into the chat while things are going on in the background. We never actually get feedback. So this is where this type of use case comes in. All right, so this is an example. Right, this is us. We're running a rulebook, and we're listening. And in this example, we're getting a payload of chat information, but it's coming through a webhook. So this webhook that comes through, we can see there's the payload information. So what is some of the stuff that's coming through? We get a channel ID, we get some channel names, we obviously get the text and the timestamps that come through. We also get things like tokens, we get the trigger word that's used, and then ultimately the user. So this is default information that comes out of the webhook when we trigger a webhook from a chat. So with this, we can use this obviously to enhance what we're trying to do from chat ops. But at the same time, we need to go focus on in terms of what we're looking for, which text we want to use obviously. From there, we can drive the automation. Because what's going to happen from a conditional perspective is this is the information that we're going to try and match. Okay, so if we're not going to try and match, we're going to at least try to do partial matches. And from there, we can drive, this process out. So I'm not too sure how many people here have ever tried chat ops. I've always liked the idea of chat ops, but typically when I start working in chat ops, I start going, okay, it's getting a little bit tricky. And I found that using event-driven Ansible, it kind of lends itself to this process, right? It's a lot easier to go and build an Ansible rulebook to decide the rules, to decide the conditionals, and then trigger out what you need. Yes, you can make it more complex. I mean, you could have a rulebook that just takes in the webhook, and from there you can drive it to a playbook which would go and process, regex, etc. Whatever you want it to do, you can make it ultimately, super complex if you want. But normally, getting started with chat ops, I found is quite a bit of a stumbling block, right? Apart from the fact that you have to go and set up bots, you have to set this up, and you have to set that up. You don't really have to do that with this. All you have to do is go to chat. Chat's working. These are my outgoing webhooks. These are my incoming webhooks. Push it through to event-driven Ansible, and then basically wait. So if we're looking at a rulebook, this is typically what the rulebook would look like if we were going to be working with this. You can see the source, obviously the webhook. And then under rules, we have the conditions that we're starting. So this is a really cool example because this has got to do with actually a network lab. But effectively, you can see that we've added basically a multi-conditional statement in there. Okay, so we have the trigger word, which we're looking for. So this is typically the word that you would use inside of the chat application that triggers off the webhook. In this instance, it's backup. And then from there, we do a partial search to try and match the text, right? So this could be anything. If you guys go and do the workshops, there's a NetOps workshop. In there, we want to back up certain switches. So what you do backup and then you do the switch host name. And we're able to take that information and obviously inject that into the different playbooks, etc., and then ultimately make sure that we've backed up the right switch as opposed to just backing up all the switches. So this is why it's really simple. So for anyone who's tried chat ops, this is a way simpler way to work, right? We build a rulebook, we just say, look, we're looking for this type of text. Based on this type of text, I want to do X, Y, and Z. Okay. What's important is you can also feed back data. So we'll see this a little bit later, but effectively we can also take output from a playbook and push it back into event-driven Ansible and drive that as a further condition. So ultimately, this is our feedback loop, and there's some important stuff here, right? So we have our event-driven Ansible that's running. Okay, we've triggered an action. That action goes through a process of, I'm going to run a playbook, I'm going to run a template. Okay. Now, you see in bold there, we have this Ansible _ EDA events. This is the namespace for the event data that gets passed on to the playbooks. So with event-driven Ansible, any event data that comes through a payload gets handed off. And typically, obviously, this data comes through as JSON, so we can go and grab those different objects, depending on what we want to use, and we can actually use it inside of those playbooks just by referring to the actual JSON object with that namespace. Okay, so that's pretty cool. Now I've got a way to link the actual information coming from the event to what I want to actually happen. Now, we have another situation there where you see another bold statement, and that's post-events from step number 2. So what happens if we want feedback from this playbook? This is where we specify what we call post-events. So post-events true will basically tell us whatever output comes from that playbook needs to go back into event-driven Ansible and we can then use it further. Okay, so imagine you run a use case where you want to update or you want to go and roll out a backup of a set of switches. You trigger that inside of your chat. Comes across as a webhook, event-driven, evaluates it, hands it off to a playbook. Now we want feedback from the playbook. So the playbook feedback, will come back to say that it's been completed, or if there is an error or anything like that. We will set facts up inside of that playbook to make sure that we can push it back. So this can be used for anything from a notification process to if something fails that we want to act on it again, or we want to do anything like that. So that's a way that we're able to feed this information back. And then lastly, I think one of the most important parts of chat ops, or at least in this component, is the notification back. So we want to be able to use this, and we can use this as a multiple action or anything like that inside of event-driven. We want to tell people, the team, that this has been completed, or there's another issue, or anything like that. So this is the loop that I typically would use, or that I use in this chat ops example, right? Okay, so let's have a look at this. I'm going to basically switch over to my laptop where I have these things running, and then from there we'll break down the actual rulebooks and the playbooks. Alright, so I've got a terminal open, and in the background I've got my chat. You can see there's already some chat messages. So if we have a look at this, remember I said Ansible Rulebook runs. It just runs and is listening to those specific events. Okay, so we have this thing that we can set up. We can say we want to do print events. This allows us to see the event payload that comes through. And from there, a lot of the times this is pretty cool because we want to test. So we don't necessarily know what's coming from the webhooks or anything like that. It's not as easy as listening to a messaging queue like Kafka. So if we run this and we trigger this, based on the rulebook that I've built, I'm listening for certain things. Right? So if I now go to my chat application, for example, and I can trigger a hello message, we can see the payload comes through. And in here, you can see already, just like we saw from the other slide, the actual payload that we're listening for. And you can see that I have an action here, which is actually a debug action. So I've matched my hello message, basically then just pushed out a very simple hello message back. And for any of you who play Diablo, I think you'll understand that reference. So if we have a look quickly at this, this is really straightforward. Oops. The logic here, sorry about that. This is really just what we're testing at the moment. So we're looking specifically for that payload of hello, right? So now let's go back, and we've extended this a little bit further. So if I run this again, and I'm listening to it, I can go back there and say, well, we wanted to remember drive this a little bit further. We don't want just something basic. Okay. So I trigger this message. Who is the best? And we get automatic response, right? Again, another Diablo reference. Necromancers are the best, and way better than other mages, right? So, how did this all work? It's pretty straightforward. Now, one thing to note, obviously, is you can see that my rulebook is still running. Okay? So, because it's still running, I can still issue more triggers. I can still say hello. Oops. There. See, it will come through. It will still trigger. It doesn't close, right? So, again, it's constantly going. So, if we have a look again at my rulebook, alright, you can see that one that I'm looking for, we're actually got a notification that I part matched that whole string basically, right? You can filter that out, obviously. You can make it a little bit more complex, like I said beforehand, in terms of using things like regex, etc., whichever ways you want to build this out further. This is just a basic example. But the two differences here is the first one that I ran with hello, we did a very basic action, right? Just a straightforward debug. But on the other one, we actually ran the playbook. So if you look at the playbook, again, it's not complex, but you get to start seeing, okay, we're triggering the chat stuff, and we're sending through things like a static message across. Now you can, as we go to the next batch of slides, you can actually go and reference this information as that namespace and obviously grab all of that information back. Okay, so let's have a look and let's break that down a little bit. Okay, so this is taken from the labs that we're running at this event at Summit. Right, there's a NetOps lab, and this is where we actually build some of the stuff later on in the lab. Now you can see there from this example the rules that we have a payload and we're searching for that specific phrase or the specific switch name. Now based on the payload that comes through the webhook, if it matches, then obviously we will go and trigger specific playbooks. We do have a way of what we call host isolation, which you will see in the lab, where we can actually just take the information out of the payload and apply that information like a different host name, and then ultimately make sure that we're only infecting at one host, right? We don't want to back up all the switches, for example. You do have the post events. Remember, we spoke a little bit about the post events, saying that we want the feedback. Why would we want the feedback? So in this example, obviously, we're doing a backup. We want to make sure that that backup actually takes place and that it completes. Hence why we want that feedback. Likewise, in the secondary condition, you can see we're looking specifically for a match, a solid match. So I just wanted to show you that there's a difference between these two, right? So the first one is a specifically for partial matches. So you could be using this basically every day if you're looking for specific issues. Maybe you're looking for like a kernel panic or anything like that. If you have this coming from webhooks or Kafka or anything like that, search specifically for these important tags that you can then use. The secondary condition is based on a match, right? So this means that that message that comes through has to say backup. If there's backup in that object, then from there we will trigger the backup or playbook. Both of them have post events, so both of them are waiting for additional feedback, right? So here, if you look, this is an example of the notification. And the thing here that's important to notice is obviously under things like BGP session, this is where we are using the namespace specifically from Ansible inside of the playbook, right? So the playbook is looking for that event data. That's how we would access it, and from there we can then use that information to build up tickets or to build additional conditionals after that. So this is an example of how we would basically do that. So in this example is a typical BGP issue. For those of you who work in networking, you see a BGP issue, we're looking for BGP states. So we would look for like an idle state on the BGP link, and from there we'd be able to action that because we would have gotten that information over the payload. Same thing with, we want to pull out information about the neighbor. So if there is an issue on that BGP, what happens? I want to be notified which neighbor switch or which neighbor network is the problem. Hence, I pull that out of that event information and I've sent it through to my chat interface. Okay, so this is a really easy example where we can explain how we grab information out of that payload from the playbook. So remember when we ran the playbook, we had post events. It means we're providing feedback. So one of the easiest ways to do this is to actually set these facts, because one of the facts are persistent, right? They run, they're persistent. They're not like event data that's going to disappear. This will always be there. So what happens is we have the different things that we're doing. You can see again very basic examples. We're checking, the BGP states on our network, and we're running a set of commands to my switches. But ultimately, we have a bunch of set facts. So now, once this runs, event-driven Ansible is going to understand all of these variables, and we can now use these variables as additional conditions. So if I wanted to say, perhaps I wanted to look at my BGP status, and if it's been set to idle, from there I can have a secondary condition inside of my event-driven to say, if this fact's been set to idle, or this fact's been set to X, Y, and Z, I need to then run another action. So this is a nice way to tie this all in, and this is why it works really nicely with chat-ops, because what happens with chat-ops, we have a trigger word, or we have a phrase that triggers the event-driven Ansible to do a bunch of automations and actions. We wait for that feedback, and based on that feedback, we will use that for notification, or any type of escalation. Maybe we want to build the escalation that the network goes down, what do we want to do? Well, we don't want to just sit there and chat. We've already notified the chat channel, but maybe this now warrants a ticket creation inside the service now. So we can drive that step further to say, okay, we've got this problem, ServiceNow now has a ticket for us, so that will go through those channels. The chat is aware of it, because all the technical teams have been aware of the notification through event-driven, and that's how we can tie it all together. We can keep that loop going from a chat perspective. So it looks like a chatbot, but it's not. It's actually just event-driven, listening to events, and basically replying and triggering different types of actions. Okay, so this is chat-ops, right, with event-driven, a really basic way of doing it without any type of without any type of bot or any middleware or anything like that. Do you have any questions around any of this? Yes? Yeah, so we have, we've got two examples of that. So we have, you'll actually see it on the NetOps lab. So in the NetOps lab, we're using GMNI, where we're bringing in network telemetry. Based on the network telemetry, we are obviously responding to different things. There's two ways of doing that with Telegraph and with Kafka. So we have Telegraph running, it's grabbing all the stuff in terms of telemetry and forwarding it through to Kafka. And from Kafka, event-driven is analyzing all the events that come through. If you have a look at the Arista plugin, Arista is doing a similar thing, but what they're doing is they're using NATS as opposed to Kafka. So they also listen to all of the telemetry that comes through from their switches, and based on that, obviously you can trigger whatever they need. There's actually a talk that we're doing with Arista Summit where they use this with Cloud Vision to gather telemetry, and then based on that use event-driven to go and automate network tasks or ticket escalations or anything like that. So yeah, there's a really cool use case with telemetry. Any other questions around this? Yeah?
Let's say if you have a couple of different rulebooks, can you run this? So my question is, if we have rules split into multiple rulebooks files, can we run one process to listen for the facts and understand them? Or
So typically what happens with rulebooks is you've seen we're running rulebooks inside of Ansible Rulebook. We do have a server kind of edition of this where from upstream we have EDA control. And basically what happens is we run the rulebook mechanism inside of a container. So we have all the ports open and we listen to this process. Now inside of the rulebooks itself, you can actually build multiple sources inside of that rulebook, just like you can have multiple actions. So you could have a single rulebook that listens to a variety of sources, and based on the events coming through, it will go and trigger what you need. Otherwise, you would run separate containers, separate rulebooks, and then basically manage that. So you can look at it that way. It becomes a lot easier when you start to work more with things like the EDA controller, as opposed to running things just on command line. Cool. Any other questions? Yeah.
Is there any kind of state with the rulebooks? Like, for example, could you trigger an alert if the webhook was called 4 times?
Yeah, there is an internal throttling mechanism that's come out where we're able to keep track of these types of things. I know what you're talking about. Like if I want to have an automatic escalation if my BGP goes out 4 times, I really need to know about it or something like that. So there is a throttling mechanism inside of Ansible Rulebook where we can actually set this up. We've done previous examples before, event-driven, where we actually reference the API back to controller, for example. We actually count how many times the job was run from a controller perspective, and from there use the logic to say, okay, well, this is clearly a serious issue. We need to escalate. But yeah, it is possible with Ansible. Cool. All right. Well, no other questions. I hope that was informative, and I hope I see a lot more chat bots going on. Thanks, guys.